Hey everyone, how are you? In this video, we are going to solve the lead code problem of the day, and the problem is minimize the maximum difference of pairs. Now the problem category is of medium level, but I would say once you watch this particular video and once you understood the problem and the solution approach as well, then this is going to be really easy for you. In this particular problem, the given input is array of numbers and let us call it as nums, and there is another input which is an integer and let us call it as p. So we are given total two inputs, an array of numbers nums and integer p, and the output which we need to give is the minimum maximum difference among p non-overlapping pairs. Now I know that this can sound very confusing, but let us try to understand it by breaking the problem. What we need to find out is the minimum value of the maximum difference among p non-overlapping pairs. Again, I repeated this part because you need to understand this particular output, what the output we need to give. Let us try to break the particular problem into some tasks, and then we will understand what does this particular statement means. What we need to do is we need to find p number of pairs in the array. Now we are given an array of numbers nums, and we are also given another integer which is p. We need to find p number of pairs in the array nums, and the pairs which you are going to create should not be overlapping. Now what is the meaning of it should not be overlapping? So let us say there are four numbers 10, 4, 3 and 8, and if you want to form two pairs out of it, then what you can do, you can form the first pair as 10, 4. Now you cannot use 10 or 4 to form another pair. So if you have used 10 and 4 to form one pair, then you will have to use other numbers to form other pairs. You will not be using 10 and 4 to form more number of pairs. For example, you cannot say 10, 3 and 10, 4 are the two pairs. If you have used 10 and 4, the other pair should not have 10 and 4. So you can have 3 and 8. Okay, these are the other pairs you can have, and that is the meaning of should not be overlapping. That is, you should not use the same element twice. Now you might say that if the numbers are 1, 1, 2, 4. Now if you make use of 1 and 2 to create a pair, you can still make use of this one. You cannot make use of this one, but you can still make use of this one and this 4 to form other pairs. This is still non-overlapping. So basically you need to form p number of pairs, and those pairs should not be overlapping. Now the next thing is you need to find the difference, the absolute difference between all the pairs. For example, if you form some pairs a comma b, c comma d, you need to find the absolute difference between the pairs. Let us say the pairs are 2 3 and 8 4. You need to find the absolute difference between the pairs. The meaning of absolute difference is the actual difference. It should not be negative. So the difference between 8 and 4 is 4, and the difference between 2 and 3 is 1. This is the absolute difference between these pairs. The next thing is, out of all the differences which you got, basically you first created p number of pairs, and if you create p number of pairs and if you try to find the absolute difference between all the pairs, then you will have total p number of differences as well, p number of absolute differences. Now out of all the p number of absolute differences, you need to pick up the maximum value. Our goal in this particular problem is to return this maximum difference out of all the p number of differences which you have got, and the other goal is we need to try to minimize the maximum difference. Now let me read this statement again, that you need to try to minimize this maximum difference. You will create p number of pairs, find p number of absolute difference, and then out of all the p number of absolute difference, you will pick up the maximum value and you are going to return it. Our goal is to minimize this maximum difference which we are going to return. So basically we need to create the pairs in such a way so that we can minimize the value of the maximum difference we can form out of all the p number of pairs. And that is what this particular statement means. The output which we need to give in the problem is we need to minimize the maximum difference among p number of non-overlapping pairs. Now let me try to explain you this with few examples. So in the example number 1, the nums, the array of integers given are 10, 1, 2, 7, 1, 3. There are total 6 numbers, and we need to form two number of pairs because the value of p is 2. So we need to create two pairs in the array nums such that the maximum value out of the difference of those absolute pairs is minimum. Now the output in this particular example is 1, but let us not focus on the output. Let us just try to create two pairs out of nums, and let us try to do it randomly. So let us say the first pair is 10, 1 and the other pair is 7, 3. So we have two pairs 10, 1, 7, 3. The absolute difference between these pairs are 9 and 4. Basically 10 minus 1 and 7 minus 3. 9 and 4, right? Now what is the maximum value of 9 and 4? It is 9, right? Now the thing is we need to return this value, but the real output is 1. That is because the pairs which we have created, the differences of those pairs are 9 and 4. The maximum value is 9. But our goal is to form pairs such that the maximum value out of all the pairs can be minimum. Can we try to find out two different pairs such that the maximum value out of the differences is minimum? Okay, let us try to do it. Let us say the pairs which we create are 1 and 1, that's the first pair, and the other pair is 2 and 3, because we need to form total two number of pairs. So 2, 3. In this case, the difference is 0. In this case, the difference is 1. the maximum value out of this is 1, and that's the output. It means that for the given nums, and if the value of p is 2, the minimum maximum difference out of all the two number of pairs we can create is going to be 1. If we are choosing the maximum value, this maximum value can be as low as possible, that is minimized. So in this particular scenario, the pairs are going to be 1, 1, 2, 3. The differences are going to be 0 and 1. Since the differences are 0 and 1, we need to choose the maximum value of these differences, which is 1, and this is going to be the output. Now this is the minimum maximum value which is possible if you will try to create two pairs out of your nums array and take the absolute differences out of those pairs. Now let us say in this particular input there is another number which is 10. So in this particular case, when the input is having another number which is 10, and this is our complete array of numbers, the output will be 0. And how the output is going to be 0? The thing is, we need to create two pairs such that the maximum difference, the maximum absolute difference out of those two pairs is minimum. Right now the answer is 1, right? But instead of these two pairs, what I can do is I can keep this pair. This is fine. I will remove this. I will not have this pair because this pair is having a difference of 1. Instead of this, what I can do is I can create other pairs which is 10, 10, and in this case the absolute difference is 0, right? Now I have two pairs such that the absolute difference is 0. 1, 1, this is 1, 1, and 10, 10, with this is 10, 10. I need to create two pairs, right? I got two pairs and the maximum value out of the differences of these two pairs is 0. So instead of the answer being 1, I can have the answer as 0. I need to minimize the value, right? I need to minimize the maximum difference out of all the p number of pairs. And that is why instead of choosing 2 and 3, I will choose 10 and 10. Now let us see one more example. The example number 2. The given nums array is 4, 2, 1, 2. The value of p is equal to 1 and the output in this case is going to be 0. What do we need to do? Out of all these numbers in this particular array, we need to form one number of pair, right? We can create a pair 1, 2, or we can create a pair 2, 2, right? We can say 1, 2 can be a pair, or we can say 2, 2 can be a pair. We just need to create one pair, right? And we will not create 1, 2. Instead of this, we will create 2, 2 as a pair because 1, 2 is going to give the output as 1. 2, 2 is going to give the output as 0. We need to minimize the value, so we will create the pair as 2, 2. So the output in this case is going to be 0. Now let us focus on the solution approach of this particular problem. Let us try to understand the solution using the example number 1, in which the numbers are 10, 1, 2, 7, 1, 3. The value of p is 2. And the first thought process which comes in our mind is, if we want to create p number of pairs, and out of this we will have p number of absolute differences, and we want to minimize the maximum value of these p number of absolute differences, can we just choose p multiplied by 2 smallest element? That is, p multiplied by 2 number of smallest element from our array and create the pair out of it. What I mean by this is, for this particular input, if you are trying to create two number of pairs, you will have to choose a total of 4 elements, right? Because one pair is going to have 2 elements, so 2 pair is going to have 4 elements. That is, can we just choose p into 2 number of smallest element out of the array? So p multiplied by 2 will be 4. Can we choose 4 smallest element out of our array and create the pair out of those array? And the answer is no, we cannot do it. That is because if we choose the 4 smallest element out of this array to form two pairs, let us say the elements are 1, 1, 2 and 3. These are the 4 smallest elements. And now we can say, okay, we choose the smallest element as 1, 1 as the first pair and the smallest element 2, 3 as the next pair. This has a difference of 0. This has a difference of 1. The maximum value out of it is 1. And in this case, the output is 1. And that is why, as a solution approach, our thought process can be, can we just choose the smallest element? Because the smallest element are going to have the smallest difference. But that is not true. The smallest elements are not going to have the smallest difference. And that is what I was trying to show you guys when I was trying to explain you the example number 1 by adding one more element in our array. We added one more element and the value of that element was 10, right? And when the value was 10, the two pairs which we created were 1, 1 and 10, 10. This is the minimum value we have in our array. This is the maximum value we have in the array. We didn't choose 2 and 3. That is because we need to focus on the actual difference. This is our focus, not the elements. These elements are not our focus. The differences are the focus here. We need to minimize the maximum differences out of two number of non-overlapping pairs. So it is not important to choose the smallest element or the largest element. We need to form pairs which can form smallest differences. So what we are going to focus on is the differences which are possible, right? So let's come back to the solution approach and let's try to answer one more question. If we cannot just choose the smallest element, so can we say that greedy approach will not work? This greedy approach may still work, and that is because, try to understand the problem here. What is the greedy approach? In greedy approach, we try to choose the current local solution or the solution available at the current step as our global solution. That is, we try to choose the first solution which is available. And that is what we were trying when we said that, can we just choose the p into 2 number of smallest available elements? But the thing is, I told you guys that in this problem, the elements are not the focus. The absolute differences are the focus. So greedy approach will not work is not true. This may still work, but our focus should be on the difference value. Instead of focusing on the numbers itself or the pairs values, focus on the difference values. That is the difference of the pairs. Now the next thing is try to search for all the possible answers which you can have. Now let me ask you guys one question. What do we want to do in this particular problem? We want to find out the minimum, maximum difference, maximum absolute difference out of p number of pairs, right? Now the thing is, what are the possible answers? The possible answers are either it can be 0. See, the thing is, the minimum difference can be 0, right? Because we are trying to find out the absolute difference, so it cannot be negative, so it can be 0. If we have, let's say, same elements, let's say 1 comma 1 or 10 comma 10, so the difference is 0, right? So the minimum answer can be 0. But what can be the maximum answer? The maximum possible answer is going to be the maximum difference which is possible between any two numbers in your data. And to get the maximum value, what you need to do is you need to create a pair of the maximum value in your array and the minimum value in your array. For example, for this particular array, what is the maximum difference which is possible for a pair? This is going to be 10 comma 1, right? The difference is 9. Now you cannot choose any other element in this particular array such that the absolute difference is going to be more than 9. And my question was, search for all the possible answers. The minimum possible answer is 0. The maximum possible answer is 9. Now the next thing is, this is the graph we have. The graph has 10 elements, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The thing is, the minimum possible answer is 0. The maximum possible answer is 9. It means our actual answer is either 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. Let us say the answer out of this is A. Let us say this is the value which we want to find out. Now the value of A can be 0, 1, 2, up to 9, anything, right? What is our goal? Our goal is to minimize this value, to minimize the answer, right? What is the minimum value of A? That's the answer we can have, such that we can have p number of pairs with a difference less than or equal to A. Now this statement can be confusing, but let us try to understand this. Now we know that our answer can be somewhere between 0 and 9. 0 and 9 are included. Let us say the answer is A. When the answer is going to be A, then we are going to have p number of pairs in our array such that the absolute difference out of those p number of pairs are going to be less than or equal to A, right? For example, in our current input, the answer is 1, right? It means that we have at least two number of pairs in this particular given array such that their absolute difference is 1 or less than 1. They cannot be more than 1, they can be less than 1. That is because we are choosing the maximum value out of all the absolute differences. And those pairs are 1 and 1, the absolute difference is 0. 2 and 3, the absolute difference is 1. So we got two number of pairs such that the absolute difference between those pairs are 1 or less than 1, right? Because we are choosing the maximum out of it. So we know that the values can either be 1 or can be less than 1. And that is what I'm trying to make you understand here. That whatever the value of A is, whatever the answer is, so we need to find a value of A in our answers, which will be somewhere between 0 and 9, such that we can have p number of pairs with a difference less than or equal to A, right? Now, what do we need to do first is, we first need to sort out our data. And why we are going to do the sorting, I will tell you. And why do we need to think about doing the sorting, I will tell you that as well. First of all, you need to try to understand how this sorting is going to help. You are going to sort your data so that searching for pairs with a particular difference could be easy. Try to understand it again. Searching for a pairs with a particular difference could be easy. Now we know that our answer can be somewhere between 0 to 9. And since we need to find out the minimum value, what we are going to do is we are going to say, okay, let us say the answer is 0. Can I have p number of pairs in my data such that the differences, the absolute differences out of those pairs is less than or equal to 0? If we have, then this is going to be the answer. If we do not have, then we will say, okay, 0 is not possible. What about 1? Is 1 possible? Okay. Do I have p number of pairs in my array such that the absolute difference between those pairs are less than or equal to 1? If we have, then 1 is going to be the answer. If we do not have, then we will say, okay, 0 is not possible, 1 is not possible. Let's try for 2. And that is what we are trying to do here. We are trying to say that we need to search for pairs with a particular difference, and we need to make this particular process easy, right? To make it easy, we need to sort the data. Let me show you why. If this is your input, which is not sorted, and if I will say that, hey, try to find out how many pairs do you have in this particular data such that their absolute difference is 0 or less than 0. Now you will say, okay, let me try with 10. With 10, I can form a pair with 1. The absolute difference is 9. No, this is not equal to 0. Fine. 10 and 2, no, this is not equal to 0. 10 and 7, no, this is not equal to 0. 10 and 1, 10 and 3. You will say, okay, with 10, I cannot make a pair such that the absolute difference is 0. Can I do it with 1? With 1, I cannot make it with 2. With 1, I cannot make it with 7. But with 1, I can make it with 1. So I can say I got one pair such that the absolute difference is 0, 1, 1. Now, my question was, do you have p number of pairs? So you will say, okay, I made use of these two numbers. Now I will not make use of these two numbers again. And out of 10, 2, 7 and 3, I will try to find out one more pair such that the absolute difference is equal to 0. Now this is going to be a really hard process. But if you just sort your data, this is going to be very, very easy. Because if you will sort your data, this is your new data now. 1, 1, 2, 3, 7 and 10. Now if I will ask you, try to find out two number of pairs in this particular data such that their absolute difference is less than or equal to 0. So what I will do is I will say, okay, let me try with the first pair. Is this pair having an absolute difference of less than or equal to 0? Yes, it is. And why I will try with the first two pairs and not the next two pairs, or maybe not 1 comma 3, because right now we did the sorting. Now, if we will skip creating any pair, let us say if this is a possible pair, which is the first two numbers, and we skip a particular number, we skip this particular number and we do not select it. At this point of time, if I select this number and any other number, right? If I try to create a pair of this number with any other number, the absolute difference is going to increase. That is because the absolute difference of 1 with any other number is going to increase because these are bigger numbers. The data is sorted. So if I create a pair of 1 comma 2 and these two numbers are utilized, then I will have an absolute difference of 1. 1 comma 2 has an absolute difference of 1. So 1 comma 2 will not be usable now because the pair is created. So now this 1 can pair with 3 or 7 or 10, right? And the differences can be 1 comma 3 has a difference of 2. Or if I say 1 comma 7, the difference is going to be 5. Or 1 comma 10, the difference is going to be 9. So you will see that the differences are getting increased. It is 1, then out of 1 comma 3 it is 2, out of 7 comma 10 it is 3, right? We do not have any pair with a difference of 0, although we have 1 comma 1. If we select this one by skipping this one, the differences which we are going to create is going to increase. And that is why we will first see with the first two available numbers that do we have this pair for which the difference is less than equal to 0. So yes, for 1 comma 1 the difference is less than equal to 0. Fine. Now let us try with 2. With 2 comma 3, do I have the difference of less than equal to 0? No. Alright, now I can say that I will skip 2. That is because if 2 comma 3 cannot have a difference of 0 or less than 0, then for sure 2 cannot pair with any other number to form a difference of less than equal to 0, because the difference is always going to increase. So what we will do is we will say, okay, these are the first two pairs, the difference is 0, fine. These are the next two pairs, the difference is not less than or equal to 0, okay, fine. We will skip 2. Let us try with 3 comma 7. We will still make use of 3, but we will skip 2. With 3 comma 7, the difference is 4, not less than equal to 0. So we will skip 3. With 7 comma 10, the difference is 3, and that was the last pair. So we just got one pair, 1 comma 1, which has the absolute difference of less than equal to 0. And we wanted p number of pairs, right? So we can say 0 is not an answer, but that is fine. Right now we are just trying to understand, is the searching process for the number of pairs with a particular difference is easy or not? And yes, it is easy. After sorting the data, the process is very easy, right? If these are all the possible answer, the answer could be 5, the answer could be 8, the answer could be 2, anything, right? Now, if this is the sorted data, we know that this is the sorted data, right? From 0 to 9, it is sorted. So what I can do is, I can, instead of doing a linear search, that is, let us say the answer is 8. And if we do a linear search, we will check for 0, then 1, then 2, and we will keep checking. And at 8, we are going to get our answer that, okay, we got p number of pairs with absolute differences less than equal to 8. Now, instead of doing it linearly, since the data is sorted, we can just make use of binary search. So now we will do the binary search in our data to see what is the minimum possible answer. The left value is 0, which is minimum. The right value is 9, which is the maximum, because our data is 1, 1, 2, 3, 7, 10. The maximum possible difference is 1 and 10, which is 9, which is a possible answer, which is not the correct answer, but is a possible answer. So we will say, let us do the binary search in our possible answers and let us try to see what is the minimum possible answer. Okay, 0, 9, so mid value is 4. Try to find out p number of pairs, the value of p is 2. So try to find out 2 number of pairs in your data such that the absolute difference is less than equal to 4. Let us try to do it. The first two pairs are 1, 1, the absolute difference is 0. So yes, it has an absolute difference of less than equal to 4. So the next two pairs are 2, 3, it has an absolute difference of 1, and yes, the value is less than equal to 4. The next two pairs are 7, 3, the absolute difference is 3, so yes, the value is less than equal to 4. So we actually got 3 number of pairs. We wanted at least 2 pairs, we got 3 pairs, so yes, if we have 3 pairs, then we definitely have 2 pairs, right? We have 2 pairs such that the absolute difference is less than equal to 4, so we will say 4 is a possible answer. Let us try to search for an answer which is less than 4, so we will reduce our search space and we will say left value is 0, right value is 4, right value is this one now. If left is 0, right is 4, the mid is 2. Now our question is, can we have p number of pairs, the value of p is 2, so can we have 2 number of pairs such that their absolute difference is less than equal to 2? Let us try to find out. For the first pair, yes, the absolute difference is 0. For the next pair, yes, the absolute difference is 1. For the next pair, which is having an absolute difference of 3, this is not counted. But we still have 2 number of pairs in our data such that their absolute difference is less than equal to 2. So we will say 2 is also a possible answer. So our previous answer 4 is now removed. This is not useful now. But right now we will say 2 is a possible answer. But let us try to reduce the value. Left is 0, right is 2, the mid value is 1. Do we have 2 number of pairs in the data such that their absolute difference is less than equal to 1? And yes, we do have. This is the first pair with absolute difference of 0. This is the second pair with absolute difference of 1. This is the next pair with absolute difference of 3. But we have 2 number of pairs with absolute difference less than equal to 1. So we will say, now the search space is 0, 1. 0 is left, 1 is right, the mid value is 0. Try to find out 2 number of pairs in our data such that their absolute difference is less than equal to 0. This has an absolute difference of less than equal to 0. So this is going to be counted. This doesn't have an absolute difference of less than equal to 0. So 2 will be skipped. 3, 7 doesn't have an absolute difference of 0. So 3 will be skipped. And 7, 10 doesn't have an absolute difference of less than equal to 0. So 7 will be skipped. So we just got one pair such that their absolute difference is less than equal to 0. So we are going to say 0 is not a possible answer. In this case, we are going to increase the value of left so that this value, the mid value, is going to increase, right? But since now the left value and right value is equal, so we are going to stop here. And the last minimum answer which we have got was 1. that will be stored in your left value, and that is going to be the answer. Let us try to see the same approach with another example, the example number 2, where the input is 4, 2, 1, 2. The value of p is 1. The sorted data will be 1, 2, 2, 4. The minimum possible answer is 0. The maximum possible answer is 4 minus 1, which is 3. So our search space is left is 0, right is 3, and the mid value is 1. Try to find out at least one pair in our data such that the absolute difference is less than or equal to 1. Do we have it? Yes. The first pair has an absolute difference of 1. The next pair has an absolute difference of 2. So we have got two pairs, 1, 2, 2, 4. One of the pair is having an absolute difference less than or equal to 1, and we just want one pair, right? So 1 can be an answer. So we are going to say left is 0, right is 1, the mid value is 0. At this point of time, try to find out at least one number of pair in your data such that the absolute difference is less than or equal to 0. We are going to say the first pair is 1, 2. Their absolute difference is 1, which is not less than or equal to 0. So at this point of time, we will say, let us skip this value of 1. We don't need this 1, but we will keep this 2. We are going to say the next pair is 2, 2 now. This has an absolute difference of 0. So yes, this is going to be counted, and we don't have any more pair now. So we are going to say we got one pair such that the absolute difference is less than or equal to 0, and we needed one pair. So 0 is a possible answer. So 0 is a possible answer. So our right value is going to be decreased. Now the search space is left is 0, right is 0. At this point we are going to stop, and the last possible answer is 0, right? That is stored in the value of left. And this is the complete approach to solve this particular problem, and this is called greedy plus binary search. We are doing a binary search in all the possible answers. And why greedy? Because we are trying to select the first two pairs. If this is possible, then we are selecting the next two pairs. If this is not possible, then in this case we are skipping one value and selecting the next pair which is possible. So this is why this is called greedy plus binary search approach to solve this particular problem. And let me take you back to the code editor and let me show you the solution for this particular problem. So this is the complete solution we have in Python. What we have is, first of all, we are sorting the data. Then we have a function. This function is going to tell us how many pairs do we have in our data such that the absolute difference is less than or equal to whatever difference we are going to pass in this function. So I will come back to this function to explain you this. First of all, try to understand the binary search logic. Once we have the data is sorted, we are going to say left is 0, right value, that is the maximum possible answer, is going to be the maximum value minus the minimum value. Now the basic binary search logic, while the left value is less than right, we are going to say mid value is going to be left plus right divided by 2. Then we are going to check if, then we will call the check function that check for this mid value, that is try to find out how many pairs we have in our data such that the absolute difference of those pairs is less than or equal to whatever mid value I am passing. And if the number of pairs which I have got is more than or equal to p, then we are going to say yes, mid can be an answer. So we are going to reduce the search space and we are going to say right is equal to mid. But if this is not true, we are going to increase the search space and we are going to say left is equal to mid plus 1. At the end, we are going to return the value of left because left will store the last possible answer. Now the thing is, we need to understand the check function. What we have right now is the starting index is 1, the current count is 0, and we are saying while the value of index is less than or equal to nums. That is, we are just trying to run a simple loop in our array. We are saying that if nums of index minus nums of index minus 1, that is the first two elements, we are taking the difference of the first two elements and we are checking if this is less than or equal to the difference, then in this case this is the possible pair and we need to count it. So we will say cnt plus equal to 1, that is the count. We are going to count this pair and then we are going to say idx plus equal to 1. That is because we right now want to choose these two pairs. So we want to skip our loop by two indexes instead of one. So we are going to say index plus equal to 1, and then when we will come out of this if condition, we will say index plus equal to 1. And now this function is going to count the number of pairs which is possible, which has a difference of less than or equal to the difference which we are going to pass. So I think this is the complete solution for this particular problem. Let me show you the complete solution. Now you can submit this code and this is going to pass all the test cases, and this is actually going to be a really efficient solution for this particular problem. So yes, you can see the runtime is really good. The memory used is good. So we have solved this particular problem in a very optimal way. And guys, I think that's it for this video. I hope that this video helps you to understand the problem and the solution approach as well. And if it did, then make sure that you hit that like button. And if you have not subscribed to the channel as of now, then make sure that you subscribe to the channel as well. And I will see you guys in the next video. Thank you for watching this video, guys.